Shrinkage can simply be defined as a change in dimensions of a fabric or garment. It's important to understand that dimensional change may be in a positive or negative direction. A positive change in dimensions is growth, and a negative change is shrinkage. Although the thickness of a fabric changes with processing and use, it is usually not significant, and we won't focus on it in this discussion. Normally, shrinkage refers to a reduction or shortening of the width or length. In garment form, shrinkage characteristics relate not only to a change in dimensions, but to other parameters such as seam puckering, skew, and relationships between the body cloth and trim components. The fit of the garment can also be affected by shrinkage. For the purposes of this discussion, shrinkage can be defined as a dimensional change in a fabric or garment caused by an application of a force, energy, or a change in environment that either allows the goods to relax or forces the fabric to move in a given direction. Cotton fabrics are unique in their dimensional instability, especially knits, which are very sensitive to forces applied in dyeing and finishing, as well as in garment manufacturing. Therefore, each time a cotton fabric is manipulated in processing, its dimensions will change. Shrinkage at any step in processing is residual in nature. Residual is defined as something that remains after a part is taken or separated, a remnant. Residual can also be defined as an after effect of an experience or activity that influences later behavior. Therefore, residual shrinkage is the amount of shrinkage in a fabric at any point in processing. From these definitions, it's understood that forces in processing that stretch fabric result in more shrinkage, and forces that contract or compress the fabric result in less shrinkage. Lack of control of these forces in processing can lead to poor shrinkage control or characteristics. As this demonstration indicates, woven fabrics are much more stable than knitted fabrics and don't react as severely to stresses. However, much lower shrinkage specifications are demanded of wovens, making the impact of processing stresses also important for wovens.